Hello all, welcome to this video, and today we are going to study the next algorithm to find the minimum spanning tree. Already I have solved the Kruskals algorithm and it's in the previous video. Now we are going to solve Prim's algorithm and we are going to find the minimum spanning tree of the given graph. This graph is containing around 6 vertices. Okay, you can see all the vertices are listed here and here, and we have also written the adjacency matrix. You can see clearly the adjacency matrix will give you the weight between every pair of the vertices. Now a and b, it is 5. You can see here a and b is 5. A and c, you can see a and c is 3, and d e f are not having any edge with a. The same way I have written all the values. You can verify once. If you take this f is having no edge with a and b. You can observe this is f. It is having no edge with a and b. It is having only 3 edges, 6, 6 and 3. So 6, 6 and 3. This way you can verify this one, and you should know how to write this. This is actually the step 1 in solving, in finding the minimum spanning tree using Prim's algorithm. Okay, now we'll go to the next step, that is step 2. This is the most important step. Let me write the table. Writing table will be more organized way of solving this question. Let me write steps. The line 1 will have steps: visited vertices, and then unvisited vertices, minimum edge, from, see, this I'll call it as yes. Visited vertices are called yes. Yes, we have visited. And G will tell you unvisited vertices. Minimum edges from yes to G, means from visited to unvisited vertices. And here we have got illustration of the graph that we have got. Okay, these are the headers of our table. Okay, this is very simple. Only you need to understand what we are going to write. Now I'm going to write step 1. In the step 1, I find that I have not visited any of the vertices, so I'll put a dash. And when I have not visited any of the vertices, obviously we will have all the vertices 1, 2, 3, 4. But here you need to write the names of the vertices. If you go here, what are the names of the vertices? You can see it is A, B, C, D, E, and F. So we'll go and write A, B, C, D, F. Let me take my pen. Now if you go here, A, B, C, D, E, F. I have not visited any of them. So minimum edge from S to G. Since I do not have any of the vertices in S, so I will not be able to write any edge values. So put it dash. And illustration, in this you will be writing the present status of the graph. If you see, I have got the graph. You need to make sure that the minimum spanning tree you will be having all the vertices. So here I have got all the vertices, but there are no edges because still I have not visited, still I have not started my journey. Okay, now I'm going to start my journey. Let me draw a line so that it will be more organized. Now coming to step 2. In step 2, you can choose any of the vertices here unvisited. From here you can choose any of them. If you want, you can choose F, E, D. Okay, let me choose D. I have chosen D. When I visit D, you see, Now imagine I reached here. When I visit D, I find that I have not visited 1, 2, 3, 4, 5. So I am going to list them in the unvisited vertices. So here I list A, B, C, D I have visited now, E and F. It's like I am dropped from the aeroplane in this particular place, and so I visited D, and there are so many other vertices which are unvisited. Okay, now that's why I have written it like this. Now minimum edge. See, to find out the minimum edge, what you can do is you can write minimum of, see, you need to find the edges from S to G. This is our S and this is our G. So I can have a edge like this, D to A, okay, and then I can have another edge D to B, another edge D to C, another edge D to E, and another edge D to F. Right. There are total 5 edges. It means D to A, D to B, D to C, D to E, D to F. Now if you go and observe, you need to find the values of each of the edges, minimum of D to A. What is D to A? Either you can use the adjacency matrix D to A, it is infinite, you can write this. Otherwise you can write from here only, it will be easier. D to A is infinite, write as it is. Then D to B, this one. Find out this one, D to B. If you look at this is D to B, 6. D to C is 5. D to E is 6 and 6. So it will be 6, 5, 6, 6. 6, 5, 6, 6. So we are going to have this as 5. Minimum of all these values is 5, and therefore I am going to choose one edge, that is D comma C, because that is the minimum possible edge. So at present I am going to have A, B, C, D, E, F. In this I am going to have D to C. Okay, what is the weight of D to C? It is 5. This is the minimum possible, right? Now I'll go to the next step. In this step, the name of this step is going to be step 3, right? And see, I I was dropped here by the aeroplane, so I was in D. Now I travel to C. So it's like I have visited. It's now like I have visited two of the places, right? I have visited two of the places. So I can write here D, comma C are the places where I have visited. After visiting these two places, I can go for A, B, E, F. These are unvisited. So if you look at this one, here you will be writing 1, 2, 3, 4, 5. There are 5 edges that you need to list here. That is actually number of elements in visited and unvisited into unvisited, 1 into 5. So we have got 5 here. Now how many we are going to get here? It is multiplication of number of elements in unvisited vertices. Here it is 2, here it is 2, and here it is 4. So into 8, right? So we'll be having 8 number of edges here. We need to list them one by one. So minimum of D to A, then D to B, then D to E, and then D to F, right? And then next C to A, C to A, then C to B, then C to D, and then C to F. And here we are going to write the values minimum of D, A, B, E and F. D, A, D, A, B, E and F. Right, D, A, B, E and F. So it is going to be infinite 6, 6. So we can write here infinite 6, 6, 6. And then next C, A, B, D, F. C, A, B, D, F. What we are going to have? We are going to have clearly infinite 2, 6 and 3. A, B, D, F. So infinite, no, see, we need to go from, okay, there is a mistake here. I need to look for EA. I need to look for EA, okay. So EA, it is not EA, it is CA, sorry, my bad. It is CA, CB, CD and CF. So CA is 3, CB is 4, CD is 5 and CF is 6. 3, 4, 5 and 6. So it's going to be 3, 4, 5 and 6. From this minimum is obviously going to be this one. Therefore this is equal to minimum is equal to 3, and here we are going to choose this particular edge, that is CA. If you go and see CA, this is going to be 3. So we have got CA now, and we can draw it in the illustration. A, then B, C, no, it is E. I don't know why there is a confusion between C and E. D, and then F. Write all the edges, and here I have got first visit, the second visit is here 3. Right, now we'll go for the next one, the next step. In this next step, what we will do is, this is step number 4. In this step, now we can see clearly that I have visited D, C and A. D, let me take my pen, D, C and A, and then unvisited will be B, A I have visited, B, C I have visited, D I have visited, E and F. Now you can see the number of edges that you need to list. 3 into 3, you are going to list 9 edges. Minimum of, you can write DB, so DB, right, and then DC and then DF. Then next C, it is not C, it is E. This is E, right? CB, CE, and then CF, right? And then AB, AE, and then AF. So minimum of B, DB, DE and DF. DB, DE and DF. DB, DE and DF, it's always 6, 6, 6 and 6. Then next CB, CE and CF. You can take it from here only. CB, CE and CF. CB is going to be, I think, 4. CE is, I think, infinite, and CF is 6. Let me verify once. CE, CE infinite, and CF is 6. So infinite and 6. Right. Now, comma. Let me have the screenshot of this here only. Otherwise it is going to trouble me a lot. Copy. Let me have it here. Now we can see the next AB, AB 5, comma, AE, AE is equal to infinite, and then again AF is again AF is infinite, right? So the minimum of this is 4, and so let me take it downside. I need it later. Okay, I'll be keeping it here. Now you can observe which particular edge we are going to choose. It is going to be C and B, CB. So you can write here CB is chosen, and therefore our illustration of the graph at this stage is this. This is 5, this is 3, and this is 4, right? And then going to the next step. In the next step, that is step 5, here you are going to write which all you have visited. Sorry, it is D, C, A, and here I visited again B. And then the remaining two are E, comma F, right? So now you must be knowing how to write the edges here. This is most important. If you miss one edge, you may be getting wrong answer. So DE, DE, and you can have CE, you can have AE, and you can have BF, right? Then next you can have DF. Sorry, let me organize it correctly. It should be BE, and then DF, CF, AF, and then BF. Okay, and so minimum of, you can get all the values from here only. That's why I have brought it here. DE, D to E is 6, and C to E, C to E is infinite, and A to E, okay, and then A to E, A to E, A to E is infinite, C to E is also infinite, then B to E, B to E is 2, comma, D to F, D to F is 6, C to F is again 6, A to F is infinite, and B to F is infinite, and so minimum of this is 2, and that is this particular edge, that is B and E. So I am going to have B and E, A, B, C, D, E, F. This is 3, this is 4, this is 5, and this is 2. After step 5, our graph is going to look like this. Now if you count the number of edges and the vertices, there are 6 vertices and 4 edges. We'll require one more edge to make sure that it is going to be a minimum spanning tree. For that, we'll go to the next step, step number 6, and here we'll be writing visited vertices D, C, A, B. In this step, we visited E also, right here E, and then we are left with only F here unvisited. Okay, let me take our matrix downside. I think I did not get the F correctly. Okay, now I'll get it. This line remained here. Let me bring the line. Okay, now this is fine. Now here I'll be writing minimum of D, F, C, F, A, F, and then B, F, and then E, F, and therefore minimum of, you find the values that you want to use. DF is 6, CF is again 6, AF is infinite, BF is infinite, and EF is 3. And so if you see this, minimum is 3, so I'm going to consider EF. And when I draw EF here, I am going to have my graph as A, B, C, D, E, and F. So these are the edges. Now if you count the number of edges, it is going to be 5. Okay, and here we have got 3. So the minimum spanning tree of the given graph using Prim's algorithm, these are the steps. See, number of steps will be equal to number of vertices that you are having in the each step. You are going to consider one vertex. Okay, and then at the end, if you count the number of edges and vertices, there should be one less than the number of vertices in the edge. Okay, and so if you find the cost of the minimum spanning tree obtained is 3 plus 4 plus 5 plus 2 plus 3 is 5, 5, 10, 14, and 3 is 17. So this is our answer. Okay, thank you.